and people. Okay, Miss Anderson, are you here? I do see you.
Yeah, I'm here.
Mr. Augustin, are you here? I don't see you. I'll try to recall.
Can you hear me, Dr. Scoop?
Yeah, I heard you, Miss Anderson. Thank you. I got you.
Okay.
Clinton, Ashley Clinton, are you in? I see your name, Miss Clinton. So I'm going to give you a yes. Okay. Curry.
I'm here.
Okay, thank you. Thank you, Miss Clinton. Your mic doesn't work, but I got you. Good, good. All right, Harris. Mr. Harris.
Oh, here.
Okay, I see you. Thank you. Miss Hollenberg. Saw you earlier. Thank you.
Here.
Okay. Holloway. I see you as well.
I'm here.
All right. Thank you. Mr. James.
I'm here, Mr. Cooper.
Right. Great. Great. Joseph.
I'm here.
I see you. Great. Logan.
Hey, I'm here.
Okay. Great. Great. Thank you. Ms. Moore.
I'm here.
Okay. Great. Thank you. Norman.
I'm here.
Okay. Great. Thank you, Ms. Norman. Paige. Miss Page. Okay. I don't see your name here. No Page. Parker. Okay, I see a name, so I'm gonna give you attendance, Ms. Parker. Thank you. Ms. Shields.
I'm here.
Okay, great. Thank you, Ms. Shields. Okay, thank you, Ms. Parker. I got your message. All right, Ms. Smith. I'm looking for your name. I don't see it. No Smith. Okay. Let me see if I can call these people. Page, I'm calling.
Dr. Cooper, can you hear me?
Yep, I can.
Okay.
Thank you, Ms. Shields. That was Ms. Shields, right?
Miss Moore,
Oh, that was Ms. Moore?
I can barely hear y'all, so I'm trying to make sure my microphone working.
Okay. I'm gonna speak up. I'll be speaking louder shortly. I'm
Okay.
kind of speaking low probably. All right, Miss Summers. Can you hear me? Summers?
I'm here.
Okay, great. And I see you too. I meant to say that, sorry. Miss Thompson, I see your name. Are you here?
I'm here.
Okay, great. Thank you, Miss Thompson. Miss Williams, Nakia. I
I'm
see it.
here.
Okay, great. And Favor, are you on the line? I don't see your name. Anybody has just joined that I called that would have been Smith or Page or Augusta?
Smith is here.
Okay, Miss Smith is here. Favor, Page, or Augusta? Did you guys making it? Okay, that's fine for now. All right, welcome. This is a good size class. I think things should run really smooth. Let's move into how things are going to work this semester. Give me one sec. I'm going to ask you guys to confirm that you can see my screen. Also, if I sound very low, let me know as well. I might have to change my mic settings to make sure you guys can hear me a little better. But also, I can speak a lot louder than this. Can you guys see my slides? If you can, would you mind just raising your hand? There should be like a little hand function. Yeah, I see a couple hands raised now. Okay, so it looks like a lot of you guys can see the slides. Okay, let's talk about organic chemistry second semester. And this is going to be spring 2021. All right. Will this work? Okay, so I wanted to review the syllabus. I don't think the syllabus is posting in Canvas. Just give me a second. There's some things that kind of changed in Canvas, so I need to go back and look at it. You should have the full syllabus here shortly. I wanted to start first with grades, all right? So I do grades on point systems. What's the difference? Typically, grades are either weighted or points. So weights are typically like homework is worth 50%, 15%, exams worth 45%, homework 20%, something like that. I don't use weights in organic. Typically, I just use the points that you earn divided by the points possible. So this is an example. Let's say that I had a student named Jill. Her quiz 1, she earned 40 out of 50 points. Quiz 2, she got 25 out of 30 points. On her homework, she got 45 out of a possible 55 points. And for her exam, she got 85 out of 100. So I take what she earned, which are all the scores for all her activities, that 40, the 25, the 45, and the 85, and I added all that up, and she earned 195 points. And the possible points are the totals that she could have earned, which was 50 for that first quiz, or 30 for the second quiz, 55 or 100 for the exam. So the total possible points for the course was 235. So I take her score of 195 that she earned divided by the possible 235, and she earns a 83%. All right, so typically in my class, homeworks are kind of scored somewhere between maybe 15 to 30 points, somewhere in that range. Quizzes are somewhat in that range as well, maybe 10 to about 25 points. Exams are somewhere between 80 to 100 points. And that's typically it. Those are the main three things that I take for grades: quizzes, homeworks, and exams. The final exam typically might be up to, it should be up to 100, but sometimes I make it weigh a little bit more depending on how the course is taught. So we'll talk more about that final exam once we kind of get through the semester. All right, is there any questions with the point system? All right, so it's not really weighted, but it's kind of weighted if you think about it, because exams are going to always be more points than anything else, right? So that means that you have an opportunity to earn more points on exam. Homeworks will total up to be a lot of points as well. Sometimes all the homeworks will equal up to an exam. So I would definitely say this for my course: homework is very, very important. It's a lifesaver for a lot of students. If you are completing homework, it's going to help a lot. That's kind of part of my teaching philosophy. I think that problems where you constantly keep working, where you don't feel pressure, is the best way to learn, right? I learned through making mistakes. I learned through just working on things. So I want you guys to use the homework to really improve your knowledge of the material. So homework must be completed. I'm sorry, that should have been a D at the end of this, but they need to be completed in Pearson's Mastering Chemistry. We'll talk more about that here shortly. Okay, so pre-lecture assignments are graded, all right? And that's, again, that should be a D here. I just making some typos. I'm moving too fast, all right? You will have 6 attempts to complete homework for maximum points, all right? So that means hopefully everyone should be able to score 100. I'm giving you an opportunity to score the best possible points you can on your homework. There are going to be 12 chapters that we need to complete this semester. So you have 12 opportunities or 12 pre-lecture assignments that you want to prepare yourself to complete for maximum points. I also will upload the post-lecture assignments, all right? Those assignments are just for practice only, and they will not count towards your homework grades. So even if you see those in your grade book, I will delete them out of the grade book before final grades are calculated. So again, use the post lectures to kind of see where you at to prepare for your exams. I would personally say that I would just open the post lecture assignments and look at the questions, right? If there's any question that I don't really recognize, I would try it and try to get the answers. If everything looks like questions I saw in the homework, you might can skip over it. All right. Keep in mind this as well. I understand that college is a balancing act. Not only are you taking organic chemistry, you might be taking calculus, you might be taking physics, etc. Those are a lot of courses that take a lot of work. So I have deadlines for homeworks, but I might at the end of the semester reopen everything. All right. Keep in mind that date that I reopen is probably going to be the last possible date. So it's not set up to help you, but if you miss a deadline, continue working on the homeworks so that at the end of the semester, if I do reset the homework dates, you will have that assignment. It'll have the opportunity to regrade itself. Okay. So keep that in mind. I do understand there's a lot of work to do, and I don't want you guys to feel overwhelmed. But if you can manage completing everything on time, it would definitely make your life easy. Okay. Don't forget that study modules will also count towards homework. There's not as many study modules for the second semester as there was in the first semester. I think there's probably a total of 3 or 4 only. But all study modules must be completed. I might not change the dates on study modules, so beware of those. I'll let you know more about those whenever we get close to when we can complete a study module. Okay, quizzes. All right, quizzes will be a mixture of Canvas quizzes. I think everyone in this course has probably taken a Canvas course before or a Canvas quiz. Typically, you just go into Canvas, you go to the quiz tab, there will be a quiz there. Most likely it will be multiple choice. All right. I will also have file submission uploads. All right. And they need to be uploaded as PDFs only. All right. Last semester, just because of convenience, I'll allow you students to turn in images and PDF files and all kind of stuff. And I did that just to make sure that people can get things done in the time restraints that I was trying to uphold. But this semester, I need to change that to PDFs only. It's just it makes things hard to grade. My grading got completely behind because I had to download files and it was taking forever for the files for me to view them, to even grade them. So if I get everything in PDFs, it makes my life 10 times easier. So we'll practice with some of the PDF uploads here shortly. I think I have an assignment probably posted for next Tuesday, that you guys will start to work with, making sure that you can upload everything as a PDF. All right. Because of the Tuesday, Thursday format, there's probably always going to be a quiz due Tuesday before class. All right. Keep in mind, there's a big gap between Thursday and the next Tuesday, right? It's almost maybe 4 days. So it's a little bit different than a Monday, Wednesday, Friday class. If you were in a Monday, Wednesday, Friday, I'll see you Friday, but then I'll see you again on Monday. Here, I see you Thursday and I don't see you again until Tuesday. That's a long gap. So typically what I do in that gap, there's going to be some type of assignment that you need to do, and that keeps us on track. I would hate for us to in class Thursday and you do nothing until you see me again on Tuesday. If that's the case, we're going to fall behind. So I'm going to help with trying to keep you guys on task with having assignments due that Tuesday, which means that you will have to do something between Thursday to Tuesday to complete that task. All right. And we'll talk more about those assignments whenever I start to upload those into Canvas. All right. Is there any questions so far on grades, how grades are calculated, how to complete homework for the class, and how to complete quizzes for this course? See any questions from anyone?
I have a question regarding the homework.
Yes, ma'am.
Once the homework is closed, will we be able to go back and view the questions for like a study guide before the test, or we won't be able to at all?
Yes, I think so. I'm not too sure how that works because I haven't, it's completely different from my end, but I need to try the student view and see. But I do believe the homework will always be, you can always view the homework even after the deadline. I think the only thing that happens is that it's the grading. If I set it to grade by, I don't know, February the 1st, if it wasn't completed by then, it won't regrade it. But I think you can always go back and look at it. But I highly recommend, even if you didn't finish the homework on the deadline, to kind of go in and try to finish it. It might tell you 0, 0, 0, 0 because it was late. But if I change the deadline, it's going to regrade itself. Okay, so I will always recommend just to complete the homework as if there's no deadline. Okay.
Thank you.
No problem. No problem. Okay. Any other questions with grades, homework, quizzes? Okay, good. All right, this is our tentative exam schedule, and this is very tentative, so keep in mind. But the chapters that that's gonna be on each exams are pretty much set. The dates of where I'm not too sure, just because of this will be my first time teaching this semester virtually or in this kind of hybrid format. So I'm not too sure how things will go. But exam 1 will cover chapters 10, 11, 14, and 19. I know that seems like a lot. It's not a lot once we kind of go through it. It's just the way that the book had organized things. The information that we need are kind of scattered in those 4 chapters. That date is set for February the 11th. That's pretty set in stone, but again, that can fluctuate. I anticipate it being done earlier than the 11th, all right? So the 11th should give us enough time to actually get a review in as well. Okay, exam 2 will be on chapters 12 and 13 only, and that should be set for March the 9th, and that's around your midterm week for this course. Again, I think that we'll be finished on those chapters way before the 9th. So that should be some flexibility there. If need be, we can actually take that exam a little bit earlier. Chapters 12 and 13 are pretty good with most students. It's a different process, and a lot of students seem to get spectroscopy a lot better than all the reactions. Okay, chapter 3 is going to cover chapters 15, 16, and 17. That's planned around March the 25th. And then exam 4, which are going to be chapters 18, 20, 21, and 22 will be near the end of the semester on the 27th. All right, and that date is the one that I'm the most afraid of. That's a lot of material right at the end. And so we probably need to push that back as far as we can. But if we move some of the other exams up, we probably could hit that 27th date. And that's my plan to do that. I would definitely update you guys throughout the semester whenever an exam date is changing or we're getting near it. But for now, you can kind of place those dates in your calendar. Okay, so the final exam is going to be Tuesday for this course, May the 4th, and it has to be taken in person. All right. If there's any issues with taking things in person, just email me and I'll try to work with you. But for the most part, we need to take the final exam in person. All right. And I'll talk more about the final exam. It's not completely set in stone, but what we're trying to do this semester, actually have you guys take the American Chemical Society organic test. What advantage that is for you guys is that you would know where you rank nationally, right? So you're taking this course, how do I match up against all the other students in the US, right? Not only locally to Mississippi, but students everywhere else. So taking the ACS exam gives you a good vibe of how much, or, where do I kind of sit with organic chemistry as a student with, the way that it's taught in all the other states, the US. All right, so that's the goal. Taking that in person just ensures that we do it the way that ACS is asking us to give the exam. So it's kind of like a private exam. They don't want it necessarily online and things of that. So again, it's tentative. We'll talk more about that once I get all the paperwork from the ACS. Okay. Also, another thing is that out of these 4 exams, I need one of these other exams to be taken in person. All right. The only reason why I'm asking this is that taking all the exams virtually just opens for a lot of potential cheating. That's the best way to say it. And so for me not to get all upset and flabbergasted and, bent out of shape, if the final exam and one of these 4 exams are taken in person, then I'll have a good clue of saying that the rest of the exams kind of match your performance and not something that's coming from outside assistance. Again, having the video cameras on and checking all that was a chore, right? So you can imagine how much work it was to grade. I had to look at video, then try to make an assessment about how people are grading. It just kind of took things to a took an extremely long time to grade material that way. So I'm trying to alleviate that with asking you guys to take one of these 4 exams in person, as well as taking the final exam in person. If you could take all 4 exams in person, that would be great. I know there's a couple of students that actually prefer to take their exams in person. So if you're that type, that's great. Again, I know there's always concerns with COVID and other things and being safe. So if you want to minimize your interactions with others, you're more than welcome to just take the final exam and one of the 4 exams in person. And again, if you're super concerned with safety, just write me as well, and I can set it up to where it's only you. The ACS exam comes in a packet that you have to open, and we time you from doing it. So it doesn't matter, as long as you come somewhere, I can give you the packet. Once I see you open it, I'll just start the timer, and then we'll start the timer whenever it's done. And again, I'm pretty sure we can find space where it's just only you taking the exam. Okay? So any questions there? And again, if there's any personal issues with this, just write me and I'll try to address all those individually. But if there's any general questions, I can take them now if anyone has it. Okay, good. No general questions. I want to move into some chemistry. Before we get into chemistry, let's make sure that everyone is comfortable with accessing the textbook. All right, so let me bring up my screen here. All right, can you guys still see the screen? What can you guys see? Can you guys see my camera screen?
Yes.
Yeah.
Okay, great. All right, so in Canvas is how you access the textbook. And I know it's a little different. Depending on your professor, it depends on how you access the textbook. Some students will access it through Pearson, My Lab, or something like that, My Lab and Mastering My Lab, I don't know, from the Pearson website. And then other students will access it from Canvas. So for my course, you can only access the textbooks from Canvas. So if you log into your course or into organic chemistry, scroll down, you'll see the My Lab and Mastering tab. Oh boy. Okay, sorry, it's not me, it's the internet on campus. All right, when you click on this tab, you should see something here that says open or access the textbook through Canvas. This is the portal that you should use to access your textbook. All right, do not purchase the book or anything like that. I will give you access codes, but I believe you guys do not need the access code, but I will send it to you shortly. I do have an access code to send. All right. But I'm under the impression because you're in Canvas, it automatically should just open a textbook, just knowing that you're a student at Alcorn. But if not, I will give the access code as well. Just give me until alpha class, I will send a message in Canvas. Okay, so did everybody hear that? I'll say it one more time. Do not purchase the book. Do not use your credit card, all right? Either the book should open automatically or it will request an access code, and I will give you the access code for the textbook, all right? And again, the way that the school has kind of worked with Pearson, it should be part of your tuition, all right? So there's some book fees, and that book fee is being applied to be able to access Pearson's textbook. All right, is there any question when accessing Canvas? Not Canvas, but accessing your textbook. All right, the only take-home point here is that you cannot access it through the website. Okay, here we go. So once this works, you should see this tab that says Open My Lab and Mastering. And I'm not too sure of the options it's going to ask you. But for me, it automatically takes me to the textbook. But for you, it might ask you to log in. And if it does ask you anything about payment, do not pay for the book. Just wait until I send over the access code. Use the access code, you should be able to access the textbook. Okay? And the e-text is here. And I'm pretty sure you guys know how to use this. When I'm looking for assignments, I just kind of scroll down to the assignments tab, and it tells you, what stuff is coming up. All right, these assignments are not made available to you yet, but I'm going to start to open these things up for you guys so that you can tell what's coming up. All right, any questions with mastering chemistry and the homework? No questions there, good. Everybody's cool with Canvas quizzes, right? So if I go to Canvas, I hit on quiz, this is where quizzes will be. All right, so most likely all quizzes will be here. Either there will be the type that you would complete here, multiple choice, or you type in something, or there will be the file upload. You want to upload all your information into Canvas, all right? And I'll send a couple reminders. Don't email me that, please. Just because my email gets clogged with a lot of other stuff. It'll be better organized if all quiz material will be uploaded into Canvas. Okay, good. All right, let's kind of move into this. This is what we're going to spend this week working on. I know you guys probably did not want to go back, but we need to make sure that we are comfortable with alkenes and alkynes. All right, I'm going to back up almost like as if you never heard these chapters. So Thursday, we're going to talk more in details about these reactions. All right, just a reminder, we said that it was 15 reactions to alkenes that we needed to know and about 11 to alkynes, all right? You will not be asked this material directly on the next exam. However, chapter 10 builds off of chapters 8 and 9, right? A lot of the chemistry of making alcohols, or a lot of the chemistry to get to an alcohol needs some of this chemistry, right? We cannot forget this chemistry. This chemistry has to become a part of you until you complete organic chemistry, or even until you complete your professional exams, right? If you're going to med school, dental school, veterinarian school, etc., this information is kind of assessed in those exams as well. So we're going to touch on these reactions again to make sure that we're ready to go into chapter 10. And chapter 10 is dealing with an alcohol functional group, okay? So at the end of the day, chapters 8 and 9 is dealing with this unique type of reaction called an addition reaction. All right, so what are addition reactions? All right, addition reactions are where we have a unsaturation, a double bond, or a triple bond, and we're adding something across it. Okay, so there's three things to keep in mind when we're trying to learn these reactions. First, we've got to know the chemical transformation. So that means which atoms are being added to the double bond and where. All right, so we talked about some of these transformations last semester. A hydration is adding water. A hydrohalogenation is adding a binary acid. So there's going to be an H and a halogen. That's fluorine, chlorine, bromine, and iodine. All right. We need to know how to do a hydroalkoxylation. All right. That's going to be an addition of an alcohol. So one side is going to get OR and the other side is going to get H. All right. A dihydroxylation. All right, this means we're going to add two OHs across the double bond. All right, cyclopropionation is where we make a cyclopropane ring. Epoxidation, is where we make an epoxide. All right, halogenation is when we add hydrogen across. Ozonolysis is when we add an ozone across a double bond or a triple bond, and typically that cleaves that bond. And halogenation is when we add halogens across. All right. There's some other reactions that I skipped over here as well, but for the most part, these are kind of some of the transformations that we want to make sure that we're comfortable with. We'll talk about how to recognize what reagent is responsible for each transformation. But rule one is to know all the possible transformations that can happen to alkenes and alkynes. All right, the next thing is regioselectivity. This is very important. Again, we'll talk this in detail more on Thursday, is which region of the double bond is getting things. All right. We talked about these terms called Markovnikov and anti-Markovnikov addition. All right. Typically, that tells us something about the regional selectivity. All right. So if I look at this alkene here, A has only one sphere, or we'll say one carbon atom attached, but B has two spheres attached, right? And that's very important for understanding regional selectivity. A will be the less substituted side, while B will be more substituted. And I'm hoping everybody is comfortable with that. Can anybody tell me, why do we say A is less substituted and B is more substituted? Can you guys tell me why?
Does it have something to do with the double bond on A?
Double bond on A. Not really.
It's
Kind of.
the number of hydrogens that's attached to it, or number of carbons.
The number of carbons or hydrogens attached. All right, that sounds kind of important. Can you break it down for me? Can anybody break that down?
Like, like A has three carbons attached, and then B has 4 carbons attached.
Okay. I think I kind of see how you're doing it. I'm gonna open Kim Draw here shortly. We're gonna talk more in detail about how to look at atoms across the double bonds. Good. Substitution is solely, before I answer, did anybody else has anything you wanted to chime in with? Anybody else? Okay. So substitution is purely upon the number of carbons attached to a carbon. All right. And we have to look at this differently. We're going to start working on this here shortly with alkenes and alkynes. When you have a double bond, try to separate only the 2 carbons in the double bond. So I label 1 carbon in the double bond A and only think about it, what's attached to it, and not anything on the B side. And I think about carbon B and what's attached to it, but not anything else attached to A. Does that make sense, what I'm trying to say there? Let's split this in half. So look at A solely and what else is attached to A, and look at B solely and what else is attached to B. But do not look at what's attached between the 2 of these, okay? So if I had to ask you how many carbons, and again, each sphere is a carbon, how many spheres or how many carbons are attached only to carbon label A here? What will you tell me?
1.
1, that's right. And if I ask you to look at carbon B and you have to tell me how many carbons are attached to it, what will you tell me? 2.
Is it 2?
That's right, 2. That's right. So A has an additional carbon, just only 1 additional carbon attached to it, but B has 2 additional carbons attached to it, right? So that means that these sides, or the 2 ends of this double bond, are they equivalent? No, they're not equivalent, right? One side has 2 carbons attached to it, and the other side only has 1 carbon attached to it, right? So regional selectivity is really saying, if I have an alkene that's not symmetric, how do I know where things go, right? Will the atom go to the more substituted side or to the least substituted side, right? And that type of discussion is very important. And again, the reagents have built into itself that type of knowledge or that type of chemistry. The reagent already is going to be influenced by the substitution pattern. So whenever I place my largest atom, and in a lot of this chemistry, there's going to be one atom that's larger than the other, right? We'll talk more in detail about that on Thursday. The largest atom tells us something about the regional selectivity, all right? So let's take a look at this product here. My X is on carbon B. Was that the more substituted side or the least substituted side? What will you guys tell me?
The more substitute.
Yeah, the more substituted side. So we have a very general way of describing chemistry like that. Whenever our large atom goes to the more substituted side, what do we call that regional selectivity? Would you say Markovnikov? All right, I'm going to say Mark. All right, well, Markovnikov. is the way that we describe reactions where the large atom goes to the more substituted side. Is everybody cool with that so far?
Yes.
Okay, good, good. And I'll say it one more time. Hearing things multiple times sometimes makes it easier to digest, hopefully. But whenever a large atom goes to the more substituted side, we call this a Markovnikov addition. So what happens when now my large atom goes to atom side A? And we said that A was the least substituted side, right? So how do you think we describe that regiochemistry? What did we say?
Anti.
This is the anti-Markovnikov addition. Good, good. All right. So not only do we need to know reagents and what type of transformation is occurring, also we need to know what type of regioselectivity is happening, right? HX does a Markovnikov or an anti. We'll learn shortly that there's a way to make it undergo a Markovnikov or to make it do the anti-Markovnikov. And that's very important for us synthetically, right? I'm going to back up here shortly. Why do we need to learn all this chemistry, right? What's so relevant about this, all right? So the first thing for a lot of students that is definitely moving into biomedical stuff, and you're going to be moving into biochemistry soon, you're going to realize that the body does chemistry just like this. Even though this is chemistry that we do in reaction flasks, the body, when it makes proteins or makes lipids, etc., is undergoing the same rules, right? It does a Markovnikov addition. It does an anti-Markovnikov addition when it makes things, right? So learning this at the chemical stage makes understanding more complicated biomedical or biochemistry related reactions make some sense, right? You learn some terms from organic chemistry that translate over, all right? But the second thing is that synthetically, being able to synthesize molecules has improved the quality of life for humans, right? I'm pretty sure you might have had a headache or a fever. You took a Tylenol for that. I have some sinuses that I'm taking Mucinex for. I'm taking some nasal spray as well that has some steroids in it because I'm getting, my allergies has gone crazy since it's got a little colder and things of that. And I've been moving around, et cetera, blah, 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 right? Before we had the ability to synthesize all these type of things, some of these illnesses or some of these problems cause people to, pass away or not be able to work. We can work longer hours. We are able to work safely because we have small molecules that are very helpful. So this chemistry is very important in a lot of things that kind of makes contemporary living very important. And for you guys to move further in life, it's always good to know some of these things so that you can pass it to your children, but also you can utilize this to kind of keep improving life for us in the future as well. Okay, so the last thing here, and it's not, I don't know what happened to my slide here, is that we want to be able to draw the products, all right? And I don't know why that slide got missing. All right, so you want to be able to make sure that if I give you a reaction, that you can draw the product, or if I give you the product, you'll be able to give me the correct reagent, all right? So before we end class today, I want to kind of move into a little bit further alkenes. All right, let's type this out. And this is a very important term here. Cis versus trans. Can anybody tell me what these terms means? What's the difference between cis and trans when it comes to alkenes?
Cis is like when it's on the same side, and trans is when it's on the opposite side.
Okay, good. What was that? That was really good. That's Ms. Moore.
Yes, sir.
Oh, I didn't surprise me. Thank you, Ms. Moore.
You're
Good, good, good. Exactly. This tells me orientation across a double bond. So let's see if we can work these out. I didn't do much as this last semester, so we're gonna get this down now. I'm going to put an OH here. I'm going to put a BR here. Okay. So let's work on this. Can you determine if following alkene is cis or trans? All right, so let's work this one out together, and then I'll give you guys a few that you will have to work out individually. Let's make this a little bit smaller. All right. So what is that trying to say? So we just said that whenever things are, let's do this. I got this alkene here. I need some circles or something. Let's see what I can use here. These things are huge. All right, so there's something very important to keep in mind, all right, is that we have to look at the alkene correctly. So what I try to do when I look at alkenes, can we determine the alkene is cis and trans? My rule one is first, label the 2 carbon atoms of the alkene. Let's bring this down a little bit. Let's go 10. Okay, so I got this alkene here, and I want to label. Actually, let's do more than this. Actually, let's make this a real example. I think that's too generic, so let's do this. Okay. What are my 2 carbons of the alkene? Is this a carbon of the alkene? Up top here. No? Yeah.
Yes.
Okay, so maybe it's not. So that's confusing. Maybe it's confusing. I'll work it out more in real time here. All right. I'm only interested in the carbons and the double bond. All right. So there's always going to be 2 carbons for every alkene. All right. So I'm going to label that side A, and I'm going to label the other side B. Are we cool with that so far? You don't have to do these steps, but these are just steps to help if you get started. And then once you guys got good at this, you probably don't even have to do this anymore. You can look at these directly and determine what's going on. Okay, so I labeled the 2 carbons in the alkene, and these are only for the double bond. Always going to be 2. Are we comfortable with that so far? Yes, no?
Yes.
Okay, good. All right, once we have labeled our 2 carbons of the double bond, now we need to look and see which carbon is higher priority, or which atoms attached to each carbon is higher priority. So I'm going to use this line here because mentally this is what I'm doing in my brain. I'm mentally separating these 2 carbons from each other. Put that in gray. All right, and I need to know the location of each large atom. All right, so on carbon A, what are my 2 groups attached to carbon A? I have a carbon and a what?
Bromine.
And a bromine. I'm going to say circle largest okay. Who's larger between the 2? Is it the carbon or the bromine? And can you guys help me out? How do I know who's larger? What do I use? What do I do to determine that?
You gotta count it, like you gotta count the number.
Count the
of
carbons.
Count the carbons? Help me, I need something else.
Are you talking about between what's larger between carbon and bromine?
How do I know who's larger? And think about it like this. Maybe I'm saying the wrong thing. Who has higher priority? Maybe I should do it that way.
Is it bromine?
Okay. Can you tell me why? Why would bromine have higher priority than?
Is it the dealing with
The rating
the
system?
term, the middle, the R, and
Go ahead. Keep it coming. Keep it coming. What was that? What was that?
is it determining the R and the S and the direction? You gotta count the car, something like that.
Somewhat. Luckily, we don't have to go that far in depth. But whenever I want to break priority, I want to say that this has higher priority than something else. What did I have to do that?
Look at its position on the periodic table.
That's right. What do you call that? This is another word for is a maybe.
Electronegative.
What was that?
Electronegative one is, but
Not
which one is more
electronegativity.
electronegative?
No, not that. Not electronegativity. I need another trend.
Atomic radius.
What was that?
Atomic radius.
Atomic,
Fine. Atomic radius.
not radius.
Atomic
Not
mass.
Not mass. Not
Atomic
mass.
number.
A number, right? Good. Atomic number. Very, very good. All right. Atomic number is what we use to determine priorities. So carbon has what atomic number?
6.
Yeah, 6. And what is bromine's atomic number?
35.
Yeah, 35. So who's higher priority? Carbon or bromine?
Carbon.
Carbon. Bingo. All right, I'm going to put a nice circle here because that bromine has the higher priority on A side, right? Is everybody comfortable with that so far?
No, can we go over that again? Why does carbon have priority?
No, carbon doesn't have the high priority. Bromine does.
Because the number is larger?
Yep, that's right. 35 is larger than 6.
Okay.
All right, good questions. Ask away. Keep asking away. Right, bromine has the higher atomic number. It's going to have the higher priority. And that's very important for us to determine if something is cis or trans, all right? We're going to have to look at the two largest groups on the alkene. Okay, let's look at B side. What's going on with B side here? I got a tie, right? I have a carbon up here, and I also have a what on the bottom?
A carbon.
A carbon. So how do I break the tie?
Is it the more?
The one that
So that one more time.
It's the more substituted carbons. Like how many carbons and hydrogens, or how many hydrogens it has on it.
Yeah, you could do that. I guess you could. Yeah, that works. I think I understand what you're saying. So look for the first point of difference, right? So when you're breaking ties, look for the first difference. And up top, this carbon has another what attached to it?
Carbon.
Another carbon. I want to put a carbon up here. But down here, what's only attached to that? Now is just what?
Hydrogen.
It's the hydrogen. Very, very good. And what is the hydrogen atomic number?
1.
Yep. Very, very good. So who wins out of
The carbon.
carbon or carbon hydrogen?
Carbon.
Good. So now our other highest priority group is this group up top, which is the alpha group. All right. So circle largest, and maybe I'll change this highest party groups. All right. Rule 3 says, now that I've done that, examine if groups, or I'll say if highest party groups are on the same or opposite sides. All right, can you guys tell me up top here, are these groups on the same side or on opposite sides?
Opposite.
Yeah, opposite.
Okay, good. Let me break this down a little bit. So just before we finalize, if they're on the same side, we call that cis. Does anybody remember the letter for cis? We talked about that last semester. It's going to be Z.
You talking about R&D? Or
All cis, it will be Z. All right, it's coming from the German word for same. The German Z is the English S. All right, so to spell the word same, you need a Z. And this is trans. I'm sorry, if they're opposite, it's going to be trans. And that's going to come from E. All right, so maybe we didn't talk about this last semester. I'm sorry, but we're going to be visiting it now. All right, so there's 2 new letters for stereochemistry. You guys remember R and S, but when I'm at double bonds, I can use Z or E. Okay. So let's go back up here. And if I need to, you could draw another line if that helps determining if something is cis or trans, or the same on the top. On carbon A, my largest party group is where? On the bottom or on the top of this?
The bottom.
The bottom, right?
Bottom.
That's right. Put this in bold. Let's make this a little bit smaller. That's the bottom here. But B, where is it located? On the bottom or the top?
The top.
Top. All right. So, because I have a priority on the top and other on the bottom, what's my orientation here?
Trans.
Trans.
Okay. Or we would say this is the E alkene. All right, we'll start naming these shortly as well. All right, did that help a little bit? Are we getting comfortable with determining if something is cis or trans?
Yeah.
A little bit, Doc, but you kind of lost me at the end.
I lost you at the end. All right, let's go back, make sure that you're comfortable at the end. All right. Let me try to clean this up a little bit. Okay, let's review really quickly. All right, I know there's a lot of little stuff here because I'm trying to split this. Let's do this. All right, so we labeled the 2 carbons of an alkene, A and B, and then we needed to circle the highest priority atoms at each carbon. So A had attached to it a carbon up here and a bromine. And we know that bromine has a higher atomic number than carbon. So the highest priority group is bromine. On B, I had 2 additional carbons, right? So I looked for my first point of difference, and I had a carbon up here, while this just had a hydrogen. So the carbon wins, and this group up here is the highest priority atom for B. So I label the carbons, A and B, and I determine where my highest priority atoms are for each carbon. Then I examine if the highest priority groups are on the same side or on the opposite side, right? So A has its higher priority group down, bottom, while B had its higher priority group where? Top. So because my priorities are top and the other one is bottom, this alkene is labeled as trans, right? Are you comfortable with that?
Yes, sir.
Okay, good. Let me change this. Let's say I have this alkene here. Can you guys tell me if this is cis or trans?
Would that be cis?
Okay. I'm gonna try to do this without labeling the carbons. I'm gonna circle the largest priority groups. So for this carbon here, which is the highest priority group? What do you guys tell me? It will be sulfur, right? Is everybody cool with that?
Yes, sir.
Right? And for the other carbon, which is the highest priority group, would be just say bromine. All right. So are these 2 groups on the same side or on the opposite side? Yeah, they're both on the bottom, right? Largest. So this makes this alkene what? Cis, also known as the Z conformation. Okay. So let's finish off with this right quick. All right, can you guys help me name this molecule? I don't know why this is all caps right there. All right, and let's not forget our rules for naming. How do we name? Can anybody help me out?
You gotta number your carbons first and count the longest chain and then name it.
Okay, there we go. There we go. I'm glad to hear that. You guys remember. All right, first I need to find the parent chain, and then I need to number that chain, and then I need to deal with substituents, and then I can name the chain, right? So what's my parent chain here?
The longest chain.
All right. And is this my longest chain that I got here?
Yes.
Yep.
Okay. Did I number this chain correctly?
Don't you supposed to count the double bond?
Okay.
Why did it go from the left to right to the left out?
Okay. Good question. So someone says, why didn't I start one the other way around? Okay. Let's do that. Let's do that version 2. Actually, I need a different color.
You're supposed to give it the lowest.
Okay. I could have also did 1, 2, 3, 4, 5 that way, right? Can you guys see that gray or is it too late?
Too light.
Too light?
Light.
All right. I'll make it purple. All right, is that better?
Yes, sir.
Okay, I'm going to go ahead and put our substituents in boxes, if you guys cool with that, just so that everyone's comfortable with that. I'm going to make that gray just because I don't want it to stand out as much. Just want it to be like a little box. All right, before we get into why we number, which number is correctly, can you guys help me out? What are these substituents called?
Ethanol.
Methyl group.
Constituents. Actually, I'll spell them out for now, but the abbreviation for methyl is going to be ME, right? Okay, good. So which numbering is correct? If we need to, we want to make sure we give substituents what? The lowest possible numbering. So if I did the red, what's my numbering for red?
4 and 3.
I have substituents where,
3 and 4.
all right, and don't forget our double bond too. That's important as well in the name. So our double bond starts where? At 2, right?
2.
So I'll say 2, 3, and 4, right? If I did the purple,
It'll
where?
be at 2. It'll
2
be at 2, 3, and 4.
and 4, right? So right now, these things look what to each other?
Identical.
They look identical, right? But there's a difference. What's the difference?
The double bond.
Double bond.
Double bond, all right? So the 2 here is really for double bond. But down here, my double bond starts where?
At 4.
4. It won't let me. My time must be up. That's what always happens when my time is almost up. All right, 4 here is for the double bond. So what do you think? Is it better to have a lower number for the double bond or a higher number for the double bond?
A lower number.
Low.
The lower numbering, all right? We'll talk more about that on Thursday as well. So the double bond is going to dominate the numbering of alkenes. You want to give it the lowest numbering. We didn't even have to work on substituents. If we give the double bond the lowest numbering, that's always correct. That's going to trump anything else. All right. So that means the correct way of numbering is red. All right. I'm going to erase the other number for now. We'll do some more of these tomorrow, or not tomorrow, but Thursday. All right. So because we gave our double bond the lowest possible number, we are ready to name this molecule. So what would we say? Excuse me. 3,4 dimethyl. What else?
Three, 4.
Dimethyl. And my
Pentaene.
PG is pit for 5, right?
Pentaene.
2E.
Is it 3, 4 dimethyl pentane?
All right, pit 2E. Yep. 3,4 dimethyl pentene, right? So my substituents came first, 3 and 4, dimethyl, pent for 5 carbons in my parent chain. And then at carbon 2 is where I start my double bond. So I say 2E, E, and E, right? There's one thing that's missing to finalize this. All right, and what do you think that is?
The double bond.
We got the double bond in, E and E, right?
You need configuration.
Is the configuration, that's right. We need to know, is this a cis alkene or a trans alkene, right? So I have to use my groups here. Carbon 2 is a double bond that we'll label A, and then B will be here. Should I do that for you guys? Should I put an A and B? Does that help if I do this? I got to figure out where my largest extension is on carbon A, where my largest extension is on carbon B. Let's make these a little bit smaller. All right, this is the A side, this is the B side. So A has just a methyl group over here. And B has what's bigger, the methyl group or this isopropyl group? What do you think is bigger?
The ISO.
Isopropyl group. This is gonna look crazy right now. I don't have a better way of trying to keep track of all this. Those two groups, are they on the same side or opposite sides? Can you guys tell?
Same.
Same.
Look at it one more time. So
Oh,
if,
dear.
Oh, that's opposite. That's opposite. I'm sorry.
yeah, if this was down here, these would be on the same side. This is down and this is up. So my orientation of this alkene is considered what?
Trans.
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 So trans has what letter? E.
E.
So to really name this molecule, we will put in front a E. Right? So the true molecule for this is E34 dimethyl pent 2E. Right? Not too bad.
No.
Okay, so I have a question.
Now.
I know time's up, but what's the other way of naming this molecule?
Another way of naming this molecule?
Yes, is this the only way, or is there another way we can name it?
This is the only way that I'm interested in seeing it. This is IUPAC past 1990. Now, some people would also put like, this is like the older version, 2E. And they would say 3,4 dimethyl 2-pent E.
I think
Right, but
it's
that-
hot outside. I think it's hot outside.
This is pre-19. This is before 1990, so they don't use this method anymore.
That's a downgrading.
It's the way that everyone names function groups is that you put the number 2 before, or you put the number before the function group. So 2 becomes before the alkene. But before 1990, you could move the 2 out and put it in front of it. Some textbooks still do this, but again, that was changed in the 90s. So it depends on the person, I guess. I was fortunate enough to be, when I was in college, they were teaching me this way, but this is before the 90s. All right, does that help? Does that answer your question?
Yes, sir.
I'm looking for it this way. Trust me, this way is a lot easier. As long as you put the number in for your function group, you'll be fine. We're gonna keep working on this. We'll make it a little bit more complicated as well, so you guys will be good. There'll be a quiz coming up on this stuff as well, so you guys can kind of reinforce working on these problems. All right, again, this is the first day. Don't worry, just the first day. All right, I'll send these to you guys, cis and trans. You can have these with notes to look over. And I also will send some practice problems with this. So if you want to, you can start to practice labeling or something as cis and trans.
Dr. Cooper, are you gonna be in your office?
Yes, I'm actually in the classroom in my office. I would say call me. Can you call me?
Yeah, I
Come
can.
see me. Come see me. The only reason why, because I've been taking allergy medicine. I don't want to cough in your face. I'm all mixed up, so I'll be coughing all day. But if you want
That's
to,
understandable.
you can. I just
All
have
right.
really bad allergies. Sorry. Okay, good. I'm gonna stop the recording.